Today we're going to do chapter 8 and the main focus is the interference of light. These are the final answers for today's questions. Questions 1. A double-slit experiment is conducted using 450 nanometer light and two narrow slits which are 0.5 mm apart. The distance from the slits to the screen is 1 meter. Find the distance y on the screen between the central maximum and A, the third order maximum, B, the second order minimum. To calculate the third order maximum, first you have to understand what does it mean by maximum. So maximum in interference, it means bright fringe. So let's apply the equations for bright fringe. Y equals to m lambda d over d. Substitute the values into the equations. You will obtain y equals to 2.7 times 10 to the power of negative 3 meter. Just a quick revision. Third bright fringe is same as the third order bright fringe. So the m for third bright fringe is also equals to 3. But when it comes to dark fringe, they are not the same. Questions B, it asks you to determine the distance between the second order minimum and the central maximum. So in interference, minimum refers to dark fringe. So let's apply the equation for dark fringe. We have y equals to m plus half lambda d. Substitute the values into the equations. You will then obtain y equals to 2.25 times 10 to the power of negative 3 meter. So again, just a quick revision. When it comes to dark fringe, second dark fringe, it is not the same as a second order dark fringe. If the questions give you second dark fringe, then the order m would be equals to 1. Questions 2. Monochromatic light of wavelength 600 nanometer is at near normal incidence on a soap film. Given n equals to 1.33, calculate the minimum thickness of the soap film, which would produce constructive interference and destructive interference of the reflected light. When it comes to thin film questions, I would always suggest my students to sketch the diagram. So let's start from a diagram. So you have 3 layers right now and it involves a soap film. For a soap film, the first surface would be the air, which is outside the soap film. The soap film itself comes with refractive index n equals to 1.33, and the inner part of the soap film, again, it goes back to air, which is n equals to 1. So now you have an incident light wave. When it is being reflected by the first surface, it undergoes pi radiant phase change because the wave is traveling from less dense towards a denser medium. Whereas for the second surface, when the light wave being reflected, it has no phase change because from second layer to third layer, the light wave is traveling from a denser medium towards a less dense medium. So the reflected wave, it has no phase change. So now you have two light waves, one undergoes pi radiant phase change and one without phase change. In this case, I would say now we have antiphase source. So for antiphase source, if you want to get constructive interference, then you apply the equations 2nt equals to m plus half lambda. And since the question is asking for the minimum thickness, in this case, we are going to assume m is equals to 0. Why? Because T is directly proportional to m. So if you want to get the minimum thickness, then you're going to use the smallest m. In this case, smallest values of m is 0. So substitute the values into the equations. You will then get T minimum equals to 1.13 times 10 to the power of negative 7 meter. And in this case, if you notice, the refractive index used is the refractive index for second layer. Questions B. To get destructive interference, you apply the equations 2nt equals to m lambda. So once again, since you want minimum thickness, therefore you want the smallest values of m. In this case, you cannot use m equals to 0. Because if you use m equals to 0, then the thickness would also be equals to 0. Therefore, for these equations, if you are going to use minimum m, then you are going to assume the m is equals to 1. So if you substitute m equals to 1, you will then obtain t equals to 2.26 times 10 to the power of negative 7 meter. So that's all for today. I will see you all again tomorrow.